Have you ever noticed how TypeScript sometimes seems to just know what type something is even when you didn't tell it? That is not magic. That is type inference, one of TypeScript's smartest features. In this episode, we are going to explore how TypeScript can figure out types automatically, saving you time and making your code cleaner. But we won't stop there. We will also look at union types, which let a variable hold multiple possible types, and intersection types, which let you combine multiple types into one powerful structure. By the end of this session, you will understand how TypeScript's type system can adopt, merge, and infer types, making your code more flexible without losing safety. Let's dive in and see how TypeScript works its magic behind the scenes. So far, we have seen how to explicitly tell TypeScript what type something should have using type annotations. But what if I told you that most of the time, TypeScript can figure it out on its own? That is called type inference. It means TypeScript looks at the value you assign and automatically determines its type. You don't always have to write a string or number. TypeScript is smart enough to infer it. This makes your code cleaner and faster to write, while still keeping all of the safety benefits so you get the best of both worlds: less typing, fewer bugs. So, why does type inference actually matter? Well, first, it saves time. You don't have to constantly write out string, number, or any other types. TypeScript handles that for you automatically. And second, it keeps your code clean. With fewer type annotations cluttering your code, everything looks simpler and easier to read. But you still get all the benefits of strong typing. And third, this is the best part, it still catches errors. Even though you didn't manually declare a type, TypeScript remembers what it inferred. So if you try to use that variable incorrectly later, it will still stop you. It's like having an assistant that fills in the details while still making sure you don't make mistakes. That is why type inference is such a big deal. It gives you speed, simplicity, and safety all at once. So now that we know what both type inference and annotations do, the big question is, when should we use which? Let us start with inference. You should rely on TypeScript's inference when the type is obvious. For example, when you're creating simple variables, assigning clear values, or working inside small scripts where everything is right in front of you. In those cases, adding a manual type doesn't give you any extra benefit. It just clutters your code. But there are times when annotations are the better choice. You will want to use annotations when defining function parameters because TypeScript can always predict what kind of data will come in. Also, when working with complex data structures like objects, arrays, or API responses, annotations make your code more readable and intentional. And if you're sharing your code with others, annotations act like built in documentation. They make it clear what kind of data you expect, so no one has to guess. In short, use inference for simplicity and annotations for clarity. TypeScript gives you the flexibility to balance the both. All right, now let's talk about one of the coolest features in TypeScript, which is called the union types. Sometimes a variable isn't limited to just one type. For example, imagine a piece of data that could be a string or a number, depending on how it is used. That is exactly what a union type allows. A union lets a variable have more than one possible type, and we represent that using the vertical bar symbol. You can think of it as saying this value can be one type or another. Unions are super useful when you're working with data that might come from different sources, or when an API returns slightly different shapes depending on the situation. So instead of choosing just one type, you're giving TypeScript a range, a safe, well defined range of what is acceptable. So we have just learned the union types, that it lets a variable hold one of several possible types. Now let us flip that idea around. What if we want to combine multiple types together into one? That is where intersection types come in. An intersection type lets you take two or more types and merge them into a single, stronger type. It's like saying this value must have everything from both of these types. We use the ampersand symbol to represent that combination. This is super helpful when you're building objects that share properties from different sources. For example, combining a user profile with account settings or merging traits of different models. So if union types are about flexibility, either or, then intersections types are about power and precision, which is both or and when it comes to logic. They give you the ability to build rich, structured types that clearly define what your data should look like. Now, in order for you to understand what we have talked about, let's have a quick demo of those topics. So let's create a new file in order for us to start our code. Let's say, for example, let's make it shorter, quick3.ts, and let's have our code here. So the first is the type inference. We will have here a variable, let's say name equals to Alice, and you will notice I will not declare a type here. I will also have here let age equals to 25 and let is online equals to true. Let's try to change this data and see if this will work. Age equals to 30 and age equals to cat. You will notice the first line of code, which is age equals to 30, is acceptable on TypeScript. However, on the second one, it's not acceptable because the error will show you type string is not assignable to type number. So if you will notice, we didn't put any annotations here, but because of TypeScript inference, it is already detected automatically that age should contain a number. So that's how inference works. Now let's have a comment on this part so it will not have an error. Let's go to the second example. Let's go to union types. So remember, union types is a variable that can have more than one possible type. Let's say, for example, let's have here let ID, and we will declare two types here. Let's have first a string, and we will have the union sign or symbol, and then let's have here number. So we are allowing this variable to have two types. So let's see if we put here ID equals to A123, 4, and you will notice that we're still not having an error. If we put here ID equals to 10, then still it is acceptable in TypeScript. But if we put here ID equals to true, that is the time that we will get an error. And it will say Boolean is not assignable to type string or number. So that's how powerful union types is. You can declare multiple types which you considered acceptable. Now let's comment this to remove the error. Let's go to the last example. Let's go to intersection types. The intersection types will combine multiple types into one stronger type. Let's have here a type keyword because we are customizing our type, not just the primitive or the built-in types inside TypeScript. So let's say, for example, we will create our own type named person, and a person should contain a property, which is name, and it should be a string, and it should also contain an age. It should be a number. Let's make this semicolon. Now, let's have here another type, which is address, and let's say it has a property city. Let's have a string here, and let's have country and another string. Let's have a semicolon. All right. Now, let's combine them into a single type. Let's say, for example, type person with address. So we will be combining these two type here into a single type. Let's have here equal sign, and then let's have person and the ampersand symbol, and let's have your address. Now, if you try to use this, let's say, for example, let user and the type that we have created, the customized type, which is person with address, it automatically should have not just name or age, just like this, but it should contain four properties: name, age, city, country. So if you will see, user is declared, but its value is never read. So let's have a semicolon first here, and then let's declare the properties and the values inside these properties. Name, let's say Alice, because In the person, that will be a string. Let's have the age. It should be a number. And then let's have city. Should be Manila. And let's have country. Let's say Philippines. So if you will also notice, the error is also removed in this part. Unlike if you try to remove one property, let's say for example, let's remove age, you will see there's an error here. But if we bring it back, therefore, the error is gone again. So we have combined two types into one, which the user variable that we have here adopted the combined properties of a person type and the address type. Thank you for watching Quick Chain Lessons by Chain Academy. If you want more courses like this, please visit our website at www.chain-academy.io.